So when I was at school, my applied maths teacher told me that the three greatest mathematicians ever were Archimedes, Newton and Gauss. I don't think I'd really heard of Gauss in those days, but I have since. And Gauss was a German mathematician, about the same time as Beethoven actually, he was born just after Beethoven, end of the 18th century, beginning of the 19th century. And one of the stories about Gauss is when he was at 7 at school, he was a child prodigy, and when he was 7, his maths teacher, or the teacher I suppose, the teacher wanted to keep the class quiet, so he gave the class the exercise of adding up the numbers from 1 to 100. And while he, I don't know, had a snooze or finished the Guardian crossword or something, I don't know what he was doing, but thought he'd keep the class quiet for a little while. But almost instantly Gauss, Carl Friedrich Gauss, he probably had a slate. You remember slates? They were great, weren't they? Slates and slate pencils. He put his slate and he wrote down 5,050 and put it in front of his teacher, which was a bit annoying for the teacher because he was meant to keep the class quiet for a while. So how did he do it? Well,
yes.
Sorry?
Take the first figure, 1, the first 100.
Yeah, I know, but he was only 7. There is of course a formula which John knows, but Gauss was only 7. He didn't know these formulae. So let's just look. Suppose you're trying to add up the numbers from 1 to 10. That's actually not so difficult. I mean, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. Plus 5 is 15, plus 6 is 21, I'm going to get lost here, aren't I? 7 is 28, 8 is 36, 9 is 45, and 10 is 55. So it's actually not so difficult, but if you imagine trying to do that with 100, you'd actually get lost, you'd almost certainly, and have to start again, which would be very frustrating. Now, mathematicians are actually lazy beings, and they actually like to find patterns which enable them to do things easily. And there is in this case a pattern, which is what John was hinting at, but John was just quoting a formula. He wasn't necessarily saying what. So let's just imagine trying to add up these numbers. I'm sorry about you people behind here, there's nothing much I can do about you.
It's okay.
But let's just write out those numbers from 1 to 10 again. So I'm just going to illustrate it with 1 to 10. And so if we write down the numbers 1 to 10, but we write them backwards, then I've written down the numbers from 1 to 10 again. So let's add up all of these numbers. Now this is actually very easy if you think about it, because if you look at the rows, rather than adding this way, let's add the rows. And each of the rows adds up to 11. And there are 10 rows, so 10 times 11 is not that difficult to sum. And you get, what do you get for 10 times 11, John?
110.
That's right. And so since the sum of all of these numbers is 110, the sum of one, and these columns are the same, the sum of each column must be half of 110, which is 55, which is actually what I got. So I actually got it right. That's remarkable. You can see if you was 1 to 100, you could do just the same thing. You'd then have 100, 99, 88 here. The same thing. You'd have each row would add up to 1 plus 100, 2 plus 99. They all add up to 101. There are 100 rows, so 100 times 101 is, oh, this is getting a bit harder, isn't it? 101 is 10,100. Again, each of the columns adds up to the same thing, so it must be half of that, gives you your 5,050. So that's how. But Gauss, at the age of 7, spotted this method for himself, which is actually quite remarkable.
Yeah.
And that's the end of my lecture.